describe the Identifying Important Science Ideas practice in the context of the It's All Connected data puzzle. So the goal of this practice is to identify important science ideas that are introduced in an interactive reading called the puzzle plot text. And we're going to do that by helping students connect ideas from the reading back to the opening scenario. So connecting ideas that they may be familiar with that are listed in the opening scenario to a new scenario, the science investigation presented in the puzzle plot text. After making those connections, we have students summarize key ideas by creating an annotated sketch, which functions as the de facto initial model. And then students identify and then make predictions for an investigative question that's presented in the text. Teachers have facilitated this practice in a couple of different ways. One, classrooms have read the whole text aloud together, pausing to discuss images that are included in the text and watch any videos that are embedded in the text. In this particular puzzle plot text, there is a virtual reality tour, a video, and a video that you can click and move in 360 degrees, so a few different interactives. Other teachers have had students read the text in small groups or individually, so up to you. We'd encourage you, if you already have close reading strategies that your students are familiar with, feel free to include those as well. So after engaging with that opening scenario where we introduce Gina Joseph and her work studying how sea ice may act as a barrier to the transfer of moisture between the ocean and atmosphere, we're going to dig in and learn a little bit more about Gina's research by reading the puzzle plot text. And so you would distribute the student worksheet here and then ask students as they're reading or following along to circle the investigative question that Gina is seeking to answer. And in this data puzzle, that is, what effect, if any, do leads, which are large cracks in sea ice, have on the transfer of moisture between the Arctic Ocean and atmosphere? And then we want students to underline similarities between the reading and the opening scenario and be ready to discuss. And so here, again, we're going through the puzzle plot text. You're watching videos, maybe engaging with the VR tour, talking about graphics, helping students make those connections. And before students answer any questions on the student worksheet, we want to facilitate a whole class discussion, a small group, then a whole class, asking students to think about similarities they may have identified between the opening scenario. Here we have Amy, runner Amy pictured without a hat, and the reading. And so here we have, this is a lead, a large crack in sea ice. We have a schematic showing the transfer of heat and moisture from the ocean to the air is happening with the absence of sea ice there. And important in this data puzzle is the direction of wind, upwind of the lead, downwind of the lead. And so that'll become more apparent why that's important later. But again, we can start to see these similarities and helping students connect their experiences and ideas to this new scenario. The science investigation is critical to student understanding. After engaging with this discussion, it's time for students to summarize these important science ideas by drawing and describing how sea ice might affect the transfer of moisture between the ocean and atmosphere based on evidence they obtain from the reading. Record the investigative question and then make a prediction about that investigative question. I'm going to pause now and head to the student worksheet so we can look at that together. So this is the It's All Connected student worksheet. You can see that we've got a couple of different videos and a VR tour embedded. We talk about how the different spheres are connected and then a little bit about Gina's work. Here's that image that shows the direction of wind and that transfer of heat and moisture from the lead, allowing that to go from the ocean to the atmosphere, and then an image of the Datahawk 2 drone. Here's a link to a 360 video where you can actually watch the drone take off and click and drag in 360 degrees. And some final text here about what increased transfer of moisture between the ocean and atmosphere, how that might impact the Arctic climate system. Moisture in the atmosphere helps form clouds, and that has implications for energy being reflected from the sun, and heat being absorbed and radiated back toward the Earth. So a couple interesting ways that clouds can impact the Arctic climate system. Down here are the 3 questions that students are going to be asked to answer after engaging with the text. One, they're going to be asked to annotate this image here to describe how sea ice could affect the transfer of moisture between the ocean and atmosphere. Students would record Gina's investigative question here and make their prediction about how the transfer of moisture will change with cracks in sea ice. After making this prediction, that concludes the part 2, identifying important science ideas practice, and students are now ready to move on to the data analysis piece, where they're going to test their prediction against some authentic data collected from Gina's DataHawk 2 drone.